Hi everyone, today we are going to talk about Gaussian summation. Let me talk about the story of this summation formula. Uh, Gauss is one of the most influential mathematicians in the world, and his full name is Friedrich Gauss, and you can also search about it. Once he was in class and teacher asked all the students to find the sum of numbers starting from 1 to 100. Let's write that sum is equal to 1 plus 2 plus 3 plus all the way up to 100. And the teacher just thought that it will take quite a long time, that students will be busy, and suddenly the Gauss answered to the question, and the answer was 5050. And all the students and teacher were amazed, and they just asked, how did you find the answer? And it was very surprising that Gauss was at a young age that time, and he just told that 1 plus 2 plus, let's write again here, 99, 98, etc. He just told that when we sum the numbers 1 plus 100, 2 plus 99, and it goes with this way, and at the end 50, 51, all will be the sum of all will be equal to 101. And we have 50 pairs, 50 number pairs here. Therefore, the answer will be 50 multiplied by 101. So we equal to 5050. The answer was correct. But let's just write this theorem in a more general way and prove it again. Let's write the sequence again. 3 plus 4 and last 4 terms, n minus 3 plus n minus 2 plus n minus 1 plus n. First case. In first case, we will just assume that the n uh, is can be divided by 2. That gives something in modular 2. 2x is a natural number, which means that n is divisible by 2. N is even number. And here our proof is very simple, as we talked about here, that if the sum is even, the number of pairs will be equal to n divided by 2, and the sum will be equal to 1 plus n, 2 plus n minus 1, 3 plus n minus 2, 4 plus n minus 3, and it will go with this with the same. And n minus 2 is number of pairs, and we will multiply it by the what is our final sum for each pair. It will be equal to 1 plus n plus 1 will be equal to n multiplied by n plus 1 divided by 2. And it's very interesting that there's in second case, when we analyze the proof for the n is odd number, whether we will get the same formula or not. This is very interesting actually. Let's just start. 1 plus 2 plus 3, first 3 term, and last 3 term, n minus 2 plus n minus 1 plus n. And we assume that our number n is odd. And when n is odd, I want to determine what is the general formula for the number the which is just between the numbers, the middle, in the middle of the sequence. Let's just write the simple sequences. with the odd number of cases, 3 through 3, 4, 5, 6, and 7, for example. What is in the middle? 3 here, and 4 is in the middle. As you see, 4 is equal to 7 plus 1 divided by 2. And let's just analyze it for another case. 3, 4, 5. The 3 is in the middle. 3 is equal to 5 plus 1 divided by 2. And when we generalize, we will get that the last term, n, which is n, plus 1 divided by 2 will give us the term term in the middle. Term in the middle. And let's just prove our theorem again. N plus 1 divided by 2, we write here, middle. And the procedure will be almost the same. And number of pairs, we will just count the, we will just make up pairs with the terms which is in the left hand side of the term which is in the middle, and the right hand side of the term which is in the middle. And we will get n minus 1 divided by 2 term. This is number of terms. Let's just change the color to make it more clear. Number of terms. And here the sum of pairs will be equal to 1 plus n, 2 plus n minus 1, 3 plus n minus 2, and again the sum will be equal to n plus 1. The sum of each pair is equal to n plus 1. And also we have one additional term here, n plus 1 divided by 2. Additional term. No term here is equal to n plus 1 divided by 2. Let's just write the formula, final formula. The number of terms which we made a pair with, n minus 1 divided by 2 multiplied by sum of each pair, n plus 1 additional term which is in the middle of our sequence. Let's just take n plus 1 divided by 2 out of the brackets, and we will get here n minus 1 plus 1 multiplied by this one plus 1, and final formula will be equal to n. This is n minus 1 plus 1, n multiplied by n plus 1 divided by 2. As you saw, we got the same formula which we had for the number of terms which were even, and the formula is the same. We got that final formula is equal to n, which is the last term of our sequence, multiplied by n plus 1 divided by 2. And this will be correct in each case. You can check it by writing different samples. And this is the end of video. Thank you for watching. I hope you liked. Please comment and subscribe to my channel.